Alright guys, welcome to this set of videos, and what we're doing is we're working our way through chapter 5, which is all about polynomials. And what we looked at in the first 4 sections where we were introduced to this idea of polynomials and how we can perform operations with them, and then we looked at polynomials as functions and how you can evaluate a polynomial for both a numerical value and using an algebraic expression. And then in sections 3 and 4, we began to take a look at graphing polynomials. So just some of the general trends, things that you can know about the graph of a polynomial just by looking at it. And then in section 4, we actually graph some polynomials using what is known as the table method, where you set up your XY table, you choose the domain values, plug them into the polynomial to get the range values, and then from that table, you can graph your polynomial, find your zeros or consecutive integers, and extrema, maximum and minimum values. What we're going to do now here in this section is going to be section 5 of chapter 5. We're going to continue with that theme, that idea of finding the zeros of a polynomial. But instead of doing it by graphing the polynomial, we're now going to look at solving the polynomial through a couple of different factoring techniques. So let's go and get some objectives or learning targets, and then we'll jump right into these. First, we're going to look at factoring polynomials. So we're going to give you several different methods for factoring a polynomial. There are a lot of different methods, and it'll really kind of be up to you, depending on the polynomial you're given, to figure out which method or combination of methods, because you may need to use more than one method in the same polynomial to completely factor, right? So it may be a combination of methods, but nonetheless, we'll go through all of them. We'll sort of give you this bag of tools, and it'll be up to you to appropriately use the tools to factor the polynomial. So factoring polynomials, and then this last one here, solving polynomial equations by factoring, which means you're going to use these factoring techniques to solve a polynomial for its roots, finding the zeros of the polynomial by factoring rather than by graphing. So here we go. Let's jump right into this. What I've done for you is I have listed out all of the techniques that we're going to use in this section, chapter 5, section 5, for factoring polynomials. Now, the reason that I've got this list, there are 7 in this list, the reason I've got this list split up is because of this. You should recognize these first 4, all right? We have looked at these first 4 factoring techniques back in chapter 4. Actually, they're from chapter 4, section 3. We learned these 4 techniques for factoring when we were looking at quadratics. All right, so we have already gone through greatest common factor, difference of squares, perfect square trinomials, and general trinomials. I will quickly review them with you again here, but if at any time as I'm going quickly through these first 4, like, wow, I really don't remember how to do that, or I probably need to brush up on that, just go back to the videos from chapter 4, section 3, rewatch that particular section. I spend much more time discussing those 4 techniques. I'm just going to review them with you here. The bottom 3 are going to be the ones we're going to spend most of our time on today, because these are really sort of the new techniques we're going to pick up here in this section. So with that in mind, we're going to go ahead and jump into this. I'm going to start running through some of these factoring techniques with you. Again, please keep in mind that as we get to bigger and bigger, more and more complicated polynomials, you may need to use more than one technique in the same problem. Okay, so it might be a combination of greatest common factor and then factoring general trinomials, or it could be a combination of group and factor, and then, I don't know, maybe GCF or something like that, right? You may have to use a combination of these guys to get the job done. So, here we go. The first one I've got for us, just in review, is going to be this greatest common factor. And remember the way it works. You're going to look at all the terms in the polynomial, and if they all have a common factor, we're going to pull it out. We'll factor out that GCF. So I go ahead and take a look at this, 4x to the 4th, 6x squared, and 12x, and what I quickly recognize is that all of those constants I can pull out a 2 from each of them. I can pull a 2 out of 4, I can pull a 2 out of the 6, and I can pull a 2 out of the 12. So I'm going to factor a 2 out of all of my constants. That is the GCF of 4, 6, and 12. 2 would be their GCF. And then I have an x to the 4th, an x squared, and an x. I can pull an x out of all of those guys. So that's exactly what I'm going to do. I will factor out that 2x, which represents my GCF. That was the greatest common factor for those three terms. What's left over after I pull out that GCF? Well, if I have a 4x to the 4th and I pull out a 2x, 4 divided by 2. 4 divided by 2 is 2. And x to the 4th divided by x is x cubed. So I have a 2x cubed left over. Negative 6 divided by 2 is a minus 3. And an x squared divided by x leaves me with an x. Minus 12 divided by 2 is going to be minus 12 divided by 2 is going to be a negative 6. X divided by x, the x's cancel each other out, and so that is what's left over after I factor out my GCF. Right? So again, what you're doing is you're looking at all of your terms, checking to see if you have a GCF of both the constant terms and the variables that are present. But remember, that GCF has to be in every single term, all right? It's got to be present in all the terms. It can't just be present in a couple of them. It's got to be present in all of the terms so you can pull it out of everybody. All right, the next one on that list was going to be a difference of two squares. Remember that this is one of those factoring techniques that is based on a formula, right? So what you're going to do is check to make sure that both of the terms you're given, they must be perfect squares. And we talked back in chapter 4, you need to know the first 10 perfect squares, right? 1 through 10, know those perfect squares, know that list so that when you see them, right, you should immediately, yeah, okay, 9's a perfect square, I got a different, right? These should jump off the page at you. You should be able to recognize them fairly quickly. So again, what I do is I just check to make sure that the formula works, right? I want to know what squared gets me an x squared. So remember what we did is we wrote it like this. I know that if I square an x, I would get an x squared. And I know that if I square a 3, that's going to get me my 9. So what I've done is I found my a, right? There's my a, and my b. Right? So it fits the different square formula, and so I can just quickly factor this guy into an a minus b and an a plus 3. So x minus 3 and x plus 3 would be my two factors. X minus 3, x plus 3. And again, because this is multiplication here, it doesn't matter which one you put first. You could have done the x plus 3 and then the x minus 3, right? Multiplication is commutative, so the order doesn't really matter. So the nice thing about this one is it does fit the formula. You just need to know the formula, and then again, you need to know that list, at least the first 10, first 12 perfect squares. You probably should know through 12. Those first 12 perfect squares, because those are really the ones we're going to use. And just recognize them when you see them. So difference of squares. Then what we've got for you is the perfect square trinomials, which once again, really pretty easy, straightforward, because you're just using the formulas. And remember, there's only these two options, and all you have to do is look at it, right? If you've got two plus signs in the problem you've been given, you're going to be using the top one. And if you have a minus sign and then a plus sign, you'll be using the bottom one. There is no minus for perfect square trinomials. It's just not possible. These are the only two options. If you have a minus and a minus, it's not a perfect square trinomial. It's going to be something else. So anyway, I take a look at this one and I recognize, okay, I got the two plus signs, so I know I need that top part. So here's what we do. I recognize right away, hey, look at that, 16 is one of my perfect squares. So let's see if it works. I know that I can do an x squared, and that'll get me an x squared. And I know that I can do a 4 squared, and that'll get me the 16. So the last thing I need to do just to check and make sure is I need to make sure that this middle part, that 8x, comes from 2ab. So here's what I got. I got plus 2 times a, which for me is going to be an x, times b, which for me is going to be a 4. So now the question is, does this give me 8x? Well, 2 times 4 is 8, and 8 times x is 8x. So yes, this guy checks out. It fits that formula, and so I know it's a perfect square trinomial, and all I have to do, right, is a plus b times a plus b. Well, my a is an x, my b is a 4, so I have x plus 4 times x plus 4, and of course, since those binomials are exactly the same, we prefer to write it squared, right? So it would be x plus 4 squared. X plus 4 squared. All right, so that's the perfect square trinomials. And then the last one, review again from chapter 4, section 3, which is what you want to go back to. If any of these are like, oh, I'm a little rusty on that, just jump back, watch those videos from chapter 4, section 3, and I spend a lot more time sort of going through them there. But here's the general trinomials. The last one we'll review from chapter 4, section 3. And remember the way these work. There's no formula. It's really just trial and error. I take a look at it and I reckon 8 is not one of my perfect squares, so it's not a perfect square trinomial. I have 3 terms, so it can't be a difference of squares. I don't have a GCF, right? I don't have anything that all 3 terms have in common I could pull out, right? So I can't do GCF, can't do difference of squares. It's not a perfect square trinomial. I don't have a choice. I gotta factor it as a general trinomial. And it really is kind of a trial and error, except, again, back in chapter 4, section 3, I gave you a couple of different methods, tricks you could use for factoring these general trinomials. One of them is what was known as the slide and divide method. And if you've forgotten how to do the slide and divide method, please, I encourage you, go back, watch that video again just to pick up that method. It's really, really nice, simple, systematic way of factoring general trinomials. You'll like it a lot if you're not familiar with it. But anyway, this one, my leading coefficient is already a 1, so I don't need to do the slide and divide method. I just write my 2 binomials, and here we go. I need to figure out what 2 terms do I multiply together to get an x squared. Well, that's the easy bit. It's an x and an x, right? If I multiply x times x, that gets me an x squared. Now what I need to do is I need to find 2 numbers that multiply to give me a negative 8 and sum to give me a positive 2. Well, actually, that's not that difficult. It turns out if I use a negative 4 and positive 4 and a negative 2, here's what I see. Negative 2 times a positive 4, well, that gets me a negative 8. And a negative 2 plus a positive 4 leaves me with the positive 2. So if I were to FOIL this guy out, I get right back to what I started with. So I know I found my 2 factors and you're all set there. All right, guys, that takes care of those first 4 factoring techniques that was on that list at the beginning of this set of notes, the ones that are reviewed from chapter 4, section 3. And again, if you need a little bit more of a refresher on how to use these techniques, please go back and watch those videos. I do a lot more example problems and spend a lot more time on them. But head on to the next page of the notes. We'll take a look at some of the new factoring methods we're going to learn here in this section. I'll meet you guys there.